So hi, I'm Josh Moore from the University of Dundee in the Open Microscopy environment, or OME. We know that most file formats that microscopy data are stored in weren't made for big data, but even fewer of them were made for the cloud. Interestingly, some very large sophisticated formats that were made especially for big data are particularly bad for the cloud, since the cloud's cost savings and performance boost all come from letting users read and write many individual objects or chunks of data. So that's why a few separate projects evolved at the same time, like XAR and N5, specifically to build a big data format for the cloud. And that's what we're calling next generation file formats, or NGFFs. So it's a bit like reading a long book online. If the book is in a single page, then you need to load the whole book up front and then spend the time scrolling down to the section that you're interested in. By breaking the book into its separate pages, you can go to a much smaller section, load that more quickly, but only if you have the right web address. So the basic trick is to make that work is taking the big data files and breaking them into as many chunks as possible that are suitable for the cloud. And that's really it. The hard part is making sure that you can find the chunks and load them quickly. So if with these new formats, we can capture more of the metadata needed for the full life cycle of our data, so including the reproducibility and quality control concepts that are outlined in the Nature Methods issue, and if we can do all of that in an open format that's also optimized for multiple use cases like cloud computing and high performance computing, we might just be able to move the bioimaging domain a step closer to truly fair data exchange.